Hello, welcome to our YouTube channel. We are Group 11 and our project today that we'll be presenting is the aerial delivery drone. And we're going to add an AI feature to this drone, which is obstacle detection. So with me, my name is Adrian Iswa. With me, my group members are
Salame Marvelous
and John Paul again.
Okay, take it down. My name is Adrian Ito and I'll be taking you guys through the electrical connection of our aerial delivery drone. Now, we are using an obstacle sensor, which is the HCSR04 ultrasonic sensor, used to measure the distance between certain obstacles. We use an ESP32 microcontroller for this, to make this happen, and to connect this sensor to our code in order to make this carry out the desired functions. So on this board now, we have our ground connected and our 3v3 voltage connected to the HS sensor. We also have our trick pin as our pin 18 and our echo pin as our pin 19. Now the ESP32 sends a high signal to the trick pin 18, and the echo pin 19 on this sensor sends that signal back at a particular length to the ESP32. The length of that signal is then used to read the distance of that obstacle from the sensor. And this is how this electrical connection and this sensor helps us to measure distances between obstacles. Thank you.
Salame I'm talking about the assembly of the drone, the Power BI and the tableau. So we first assembled all the motors on the drone by mounting it with an iron key, and they are all brushless motors. And we also mounted the propellers on it. So here, the other parts of the drone that we don't mount because we don't want to be mounting and removing it so that it won't damage it. So we have the motor controller here, we have the battery regulator, and we also have what will connect the battery to the flight controller. So these two terminals will be connected to each terminals of this board that we'll use to power the flight and the motor controller, and this will also be connected to the flight controller. As you can see here, normally this is how ours should look like, but we don't have all the components. So yeah. So I'm talking about, the other thing I'm talking about now is the Power BI and Tableau. So I imported the data which was on an Excel spreadsheet into the Power BI, which had 3 different columns: the date, the time, and the distance. We created a pie chart, a bar chart, and a line chart of the time against the distance, which could be shown here. We also did that on the Tableau. Here, this is the line charts. As you can see here, the line chart got to 800 centimeters because of what we were measuring from the sensor was farther away than how it was normally. And also the bar charts. Yeah, it was shown here. So the distance against the time. Yeah. Thank you.
Good day everyone, my name is John Paul again, and I will be taking you guys through the Arduino code and data logging. First of all, let's be minded that where I am placing this is not the supposed place we want to put this. This is still a prototype version. This ultrasonic sensor will be placed directly in front of this place, but due to the components, we don't want to be unplugging and plugging back because that has damaged some components for us already. So now let me take you guys through the data logging, through the Arduino code. So if you come to my laptop, you can see that this is our Arduino code, the trick pin 1819, and so connected on the ESP32. Now if you come to the serial monitor, you can see that yes, that this is taking readings. You can see, because initially what we planned was to use 2 sensors, one for front, one for back, but I say this is an initial phase. So now this code is for the front distance. So as you can see, it is taking reading 35.2. If I put my hand
changes to 3.0. So as my hand draws closer to the sensor, the readings will be changing. Now I hope you guys can see that. Yes, so as my hand draws closer, it will be changing, it will be fluctuating. Now the question now is, how do I log this to the data, to the Google Sheets? So now one of the issues we encountered was we have an issue. I don't know, maybe it's from the ESP32, who knows? It was not connecting to Google Sheets. So we say, all right, let's try a different way. So say to write a Python code. So this Python code is meant to extract what the readings is getting from the port I connected this ESP32 in. From the port I connected, then to go and plot it on the Google Sheet directly, rather than trying to use the Wi-Fi method and everything, which causes us a lot of trouble. So now, in order for this method to work, I have to close the Arduino IDE so it does not, because the Python is using the COM I connected it, so that the Arduino IDE and the Python does not clash. So now I'm going to show you how to run this Python code. So I go to run. I'm using a Python ideally, I'm not using the Visual Studio Code. Now I wait for the code to boot. To take its time. It has started running. As you can see from here, it is showing logged. So anytime it's logged, the Python code will tell me it has logged and to show me the value it has logged. Now let us go to the Google Sheet and see what it is logging. What is the time? The time is 2:32 p.m. but this is logging in 24 hours format, which is no problem. As you can see, it logs in every second. If I put my hand on the ultrasonic sensor, the reading should be able to fluctuate. So it logs in. It will take time to fluctuate here because of the port and everything. So because the Python code is collecting and everything, so that will take a bit of time to, but you can see it's also fluctuating. So yeah, you can also see it's logging. So this is how we plan to log in our details. Thank you.